So for those of you guys just joining us, we're looking now at number 25. Kim had this question. It was a little weird because it asked us to sometimes do 4 and then 8, then 20, then 50. And there's no way they expect you to actually type out 50 rectangles. So I was like, hey, remember, there's this cool summation that will do repeated sums for us. This is an important formula. You might want to put a star by it. And here's how it works. A is the beginning of the shape, which is 0. B is the end of the shape, which is 12. I have pancake batter on me. Anyway, and then here's my function, negative 1/3 x plus 4. So in plugging into the sum, which our calculator can do, in this f of spot, I'm going to have negative 1/3 from my function over here times, we'll get back to that, 4, I should say, times this expression. We're going to have to get that in a second. And then the plus 4 finishes us off, times, and then b minus a, well, 12 minus 0, all over n. 12 minus 0, all over n. And then over here, we're going to have a, which is 0, plus b minus a, 12 minus 0, all over n times I. Now, we're going to simplify this just a little bit, just to make it easier to put into our calculator. So we're going to end up with negative 1/3 times 0 plus anything is itself, 12 minus 0 is itself, so we're going to have 12 over n times I, plus 4, all times 12 minus 0 is just 12, all over n, with our sigma out here. So all I have to do, Kim, to plug into that table is basically say, okay, well, what if n is, do you guys have it right there? Is it 4, and then 8, and then 20, and then 50? Okay. So all we have to do is just plug it into our calculator and say, okay, every time when we go to do this math and then go up to summation, we can do x instead of I, that's fine, from 1 to, okay, well, the first one's going to be from 1 to 4 because my n is 4. And then when I go to plug into my calculator, I'm going to have big old parentheses of, here's my negative 1/3. I need another parentheses, sorry. And then I have my 12 over, now wait, who's my n for the first one? 12 over 4. All times my x, or times my I, plus 4. That ends my first expression, so I have, that's the end of this guy. I still needed to get my 12 over n, and 12 over 4 is what I'm looking at. Now, that wasn't very pretty, so if you wanted to, you could always make it a little bit prettier. For instance, you could have right here done alpha y equals and done a little negative 1 over 3. That would have made it a little bit prettier. You could have had your, this guy, once again, be alpha y equals. You could have done your 12 over 4 times I, if that's a little bit nicer for you, plus 4. And once again, you could have done your nifty little alpha y equals to make it pretty and make it a little easier for your brain to process. This might have made it a little bit easier for you guys to see, but either way, you still end up with 18. So 18 would be the first one. How do we finish this table off? Yeah, just change your ends every time. So you just come right back on up and say, okay, this is the exact same thing, but instead of 4, now I'm going to go ahead and use 8. And then everywhere there's a 4 in here that was from the n, I'm going to change it to be an 8. That 4, though, is a part of my formula. I'm not changing that 4. Only the 4s that were a result of my formula. So now I'd have 21. Does that make sense, Kim? Just keep on going. Change to 20, change to 50, and then you're good. But the key to this one, doing it by hand, making 50 rectangles, no way, Jose. Use this formula. And then, Vico, this is a perfect lead into number 43. Because number 43 has you setting up this very formula, but instead of going to 4 or 8 or 20 or 50 rectangles, instead, in number 43, we're going to infinity. We're finding the exact, which we just learned how to check that, right? Using our little nifty, difty integral. We can check and see if we're right, but Tony said the limit process is another way to solve. So for number 43, I see the function, wow, it just got really fuzzy, and I apologize. 8 minus x cubed. Let's see if it can focus in at all. There we go. For number 43, we have 8 minus x cubed, and we have 1 to 2. So let me go ahead and get that in. So I'm doing the limit as n goes to infinity of, now I'm going to put off to the side, so I have my f of x is 8 minus x cubed. Here's the cubed one I was talking about that Adam and Kathleen were doing on the board yesterday. 8 minus x cubed, and what's my boundaries? 1 to 2? Okay. So my a is 1, my b is 2, and my f of x is 8 minus x cubed. So my a is 1, my b is 2, my f of x is 8 minus x cubed. So when I go to plug into my formula, a is going to be a plus 1 plus b minus a, 2 minus 1, all over n times I, all times b minus a, 2 minus 1, all over n. I'm plugging in right now, guys, to this formula I put a star by just a second ago, because now I have a new a and a new b, so I'm plugging into that formula. All that I have left to plug in is my f. He's my last piece. So I'm going to go ahead and say, okay, this is equal to the limit as n goes to infinity. I equals 1 to n. Of 8 minus, he's my function. Who cubed? Well, 1 plus 2 minus 1 is 1. 1 over n times I, or I over n is another way of simplifying that. Cubed times 2 minus 1 is 1 over n. Oh, I had to plug this in. F of x, this gets plugged into the x spot. So I plugged this into the x spot. Yeah. Okay, so here's the sad part. In order to take a limit, I need to get a formula. And in order to get a formula, I have to rewrite this. And in order to rewrite this, guys, look on the front board. Don't I just have sums of c and I squared and I cubed? Sad thing is, I need to simplify this cubed. So without doing tons and tons and tons of extra work, I'm going to use Pascal's triangle just to get this piece. So I can come on back over here and plug it in. So when I do this, I'm going to have 1, 3, 3, 1 from Pascal's triangle. It's a cubed. I'm going to have 1 cubed, which is just 1, times him to the 0, which means he's not there. So that's just a boring old 1. But then I have 3 times 1 squared, which is still just 1. But all of a sudden, the I to the n comes in, or the I over n, to the first power. Then I have 3 times 1 to the 1 power, which is still just 1. But now this guy is being squared, so I squared over n squared. And then last but not least, I have 1. This guy's gone, 1 to the 0 power, and he's now cubed. I cubed over n cubed. Once again, this is way harder than anything tomorrow. Tomorrow you might just be able to distribute or maybe foil like a squared, but nothing cubed. Cubed is a bit harder than you'll see tomorrow. So at the end of the day, I get 1 plus 3i over n plus 3i squared over n squared plus I cubed over n cubed is this dude, and this is what I'm going to come over here and plug in. So I can say 8 minus 1 minus 3i over n minus 3i squared over n squared minus 3i cubed over n cubed. And all of that is times 1 over n. And this is inside a summy dude, beep, 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 and inside a limit. Now, I can throw this 1 over n into everybody. I could make 8 minus 1 to be 7 instead, just to make life a little bit easier. But if I was to bring this 1 over n into everyone, I'm just going to up everybody's. I'm going to cross him out, and this is going to be to the 4th power. He's going to be cubed now. He's going to be squared, and now the 7 is going to be over n. And it's time for me to, with those formulas on the board, get rid of all the sigmas. So to get rid of all the sigmas, I have to think through every single piece. 7 over n. Are there any i's in this, guys? No. So 7 over n is going to be like a c. Can you guys tell me what I do if there's a sigma of a c? What does that end up becoming? I multiply it by n. Good. So 7 over n, who I have, is going to be times n, which actually puts the n in the numerator. Minus. Now I'm going to have 3 over n squared. But guys, now I have an I. What does I become? N times all over 2. And then I'm going to have a minus 3 over n cubed. But now I have an I squared. What's that going to become? And then I'm going to have a 3 over n to the 4th times, what's I cubed become?
N squared times n plus 1 squared over 4.
Okay. Do you see where I'm at? I now have a big old piece to take a limit of. How do I take limits to infinity when I have fractions? Good. David and Goliath. I do the degree test. Kyle.
When you're multiplying n to 7 times n, don't the n's just cancel?
Yeah, you could. You could just have the n's cancel. But what I was about to do right now was to say the degrees are tied anyway. And if the degrees are tied, don't we just take the ratio of the leading coefficient?
Yeah.
So yeah, in essence, the n's do cancel, and we just get 7. Minus. Can you guys tell if the degrees are tied or if the top or bottom wins in this next piece? Tied, because this guy's an n squared and that guy's an n squared, but what's the ratio of the leading coefficients? With a minus in front, right? So minus 3 over 2. How about this next guy? If you do n times 2n, would that be a cubed?
Yes.
Okay, so degrees are tied. On the bottom, I get a 6, and on the top, 3 times 2 would be a 6. Oh, well, 6 over 6, isn't that just 1? Okay, how about this guy? I have an n squared and an n that's going to eventually be squared. Won't that be n to the 4th? And that's n to the 4th, so minus 3/4, ratio of the leading coefficients. Ew, what does this end up being? Well, if I was to make 7 into 4ths, wouldn't that be 28/4? Minus, this into 4ths would be 6/4. This would be 4/4. This is already 3/4. So what's 28 minus 6 minus 4 minus 10? That's 18. And 18 minus 3 is, wait, 28? 15/4? Double checking. 28 minus 6 minus 4 minus 3. Let's check it. How do we check it? Remember that really cool one? Function integrate. We're going from 1 to 2. Of my function 8 minus x cubed dx. What's 15 divided by 4? Ruh-roh. It's supposed to be 17/4, isn't it? Oh yeah, how'd I get a 3 in there? I don't know, because it was 1, 3, 3, 1. I did 1, 3, 3, 3. I don't know why I randomly put a 3. That was some sort of magical craziness.
That's not math, it's not magic, it's math.
Yeah, no, that was just black magic right there. Because we pulled that in, and then I multiplied. Yeah, when I multiplied by 1 over n, I made it a 3. Thanks, Tony. If it's only 1/4, then it's 17/4, and I think we're a whole lot better. Because 17/4 is 4.25. Ha ha! Bum-ba-da-dum-bum-bum-bum. Phew. Okay, so we looked at 2 much nastier examples than you'll see tomorrow. However, they're both good ones to look at as far as if you were to have something with rectangles, how to approximate, but it'll be fewer rectangles. And if you had a limit process to find an integral, but with a much easier function than a cubed. Man, that cubed was nasty. That cubed was nasty. If you guys want, in our notes from yesterday, I think, didn't we have an easier example than the cubed?
Perhaps.
I'm pretty sure we did. We had this example of x squared, and it was a whole lot easier to plug in. The math wasn't near as complicated, and we did our little degree test at the end and had a 1/3 pretty fast. So if you want, you can watch the video from yesterday for an easier example, but today we got to do that hard example with this nasty n cubed one, or I should say I cubed one. We had to do Pascal's triangle. Ugh. Okay, let's go peek at the worksheet real fast. How did this go? Man, it must have been so much worse than the book homework. I'm kidding. Why? What's the derivative of any constant? What'd you get? 0. Right? What's the derivative of 4x to the 5th? It's what you should have already in your homework, right? What'd you guys get for number 3? 20x to the 4th plus 1x to the 0 is just 1. What'd you guys do for number 5? Did you bring down the 5/4 and get 15/4 x to the, what was the new power? 1/4, because 5/4 minus 1 is 5/4 minus 4/4. Yeah, it makes everything a lot easier. How'd you guys do number 9? Oh wait, number 7.
Oh, I did -5 times what's it? -4
Yeah.
was 20, and then when I put the exponent up to the top, it only root it. I forgot to root it.
Oh, you didn't have to root it actually. It was a little bit easier than that, Robbie. But you're right. Number, were you saying root?
I was saying 5th root.
Oh, you're getting confused between 7 and 9, but they're both tricky for different reasons. Number 7, you're totally right. Would have been 20. But then the -5, you just have to take away, oh, not, sorry. I went to the answer. You just have to take away 1 like normal. And this one, you would have brought down the 2/3. And you would have taken away 1 like normal. But when you take away 1 from a negative number, what do you guys get?
-6.
Yeah. And a negative exponent, if you want to rewrite it, which you don't have to. I think on the test, I let you just give me an answer. It doesn't have to be a multiple choice, just an answer. So you could stop here and be like, ha. Or you could be like, ha. It's the same thing. I would take that. Good. I would take that. Good. Tomorrow if I hear a little ha, that's good as long as you're not like ha to someone else. That's not good.
Oh, no, she.
But anyway, but what's different? This is the root one, Robbie. This is the one you're thinking of.
Yeah.
When I take away 1 from 2/3, I would take away 3/3. Life is so much easier if you just make it a little improper. Sorry, a little fraction. And what's 2/3 minus 1? Sorry, minus 3/3. Keep on trying to give the answer. My brain's just working too fast. And that's where, now once again, box it. You're good. You're right. I would give you full credit. But if you want to be super snazzy, just be careful you don't make it wrong, or else I have to take away credit. There's the cubed root.
Oh!
The 1/3 says cubed root, the negative says denominator. Please don't. Please don't simplify. Please don't simplify. But guys, there was another page to that worksheet. I just wanted to make sure you got the right answers. Although you could have chucked them at the end, right? Shouldn't that have been 8/3 x cubed plus 5 plus 3x to the -4? Right? You didn't have to simplify. You could have stopped there. But what were you doing once you got to the very end of the worksheet and there were other letters? Same thing. It'd just be -15r to the 4th minus 10r to the 1, right? No big deal?
Good.
Fractions, you have to be a little careful of, but I think I'm pretty nice tomorrow on fractions, just a heads up. And with this one, this was a little tricky. It's trickier than tomorrow will be. But they say that c is a constant. Well, if 5 is a constant and c is a constant, there's no x. What's the derivative of any constant?
Yeah.
Which is why the answers for this last one should have shown you that 17 was, in fact, 0. And these ones, they might have written different ways. They might have written it all nice and pretty and simplified and all that jazz. But remember, as long as you have a correct form of the answer, I don't mind tomorrow. Sound good?
Sounds good.
Okay. So let's talk about the test tomorrow. Once again, here's your test review. You
Okay.
guys are going to have about 10 minutes to work on it. I'm going to walk around and see if you guys have any questions for me. Remember, everything is practiced in the test review except for the worksheet. But there are some evens we hadn't done yet, so maybe you could play with some of the evens. The answers are there. You can play with those. I don't mind. So as far as the test tomorrow, hints. Are you ready?
Hints.
Yeah, you can grab a book if you need one. No problem. Hints. You are going to have to find limits.
Wow.
Order in the limits chapter. There's one table I asked you to fill in. There's one table I asked you to fill in showing me the approach, but then give me the multiple choice answer. Most of the limits you can just plug in, but sometimes I give you a graph, sometimes I give you a table. Guys, when does a limit not exist? What if there's a hole? but the two guys agree? What if there's a hole, but the two guys agree?
Then it's like error.
In the table, it's an error, but in the limit, look at your shoes. Wouldn't it match?
Yes.
Would they go in the same place?
Uh-huh.
So the limit exists even if there's a hole, as long as they're going the same place. When does the limit not exist? When they're going different places. So, as long as the two cars, the two guys headed to In-N-Out, as long as they're headed to the same place, even if there's a hole, the limit only does not exist when they don't agree. When they're headed to different locations. Or wasn't there a weird like bouncy one where that one didn't exist either? It's called oscillating. I think this is section 12.1 at the end, when the limit does not exist. Okay, you're going to have to do a couple derivatives the long way. What do I mean by that?
Using
the difference quotient?
Yes.
Yeah, using the difference quotient, using this one up here. You're going to have to do one or two like this, but then don't you have your shortcut rules for the next, like the worksheet? So you're going to have to do a couple the long way with the difference quotient, but then you get to use your shortcuts for the rest. What happens if you plug into a limit and you get 0 over 0?
Keep going.
Yeah, good. How do you keep going? Factoring. That's one way. Factoring and canceling out. What if there are square roots? Multiply by that. You're saying difference. The conjugate. You have to multiply by the conjugate. This was section, I think, 12.2. Section 12.2, the tricky things of how to take limits when you get 0 over 0. How do you take limits to infinity again? The champions, right? David and Goliath, the degree test. So peek over limits to infinity. And then otherwise, it's going to be area stuff like we talked about today. Approximating area, exact area, and then the shortcut rules from taking derivatives in the worksheet.
And then those formulas again.
Except, can I see if there's one example? There's one other type. Do you remember how sometimes for limits we could just come from below or just come from above? Remember that? The little plus or the little minus? I thought I had one here. Maybe I don't. Before derivatives, before tangent lines. Did I not? Oh, I thought I did.
Oh no.
It's okay. I can show you one from pre-cal.
It should not put.
I think I have an example in theirs. I had it here, just it's not quite as good of an example. Where there was like a plus and a minus. Ah, here we go. Where you can come from just one side or from the other. And I gave you an example, but it wasn't a very like super specific example. I think the book might have had some more, but coming from below or coming from above. Let me go see if I have a better example from pre-cal's notes. I think I saw one yesterday. If it opens. Here we go. Where's their example? Oh, here we go.
What?
How would you do this one, guys? What would the limit be as x comes towards 1? Is that from below or from above? From the left or from the right?
From what?
Yeah, y from the left is a number a little bit below 1, like 0.9. And where would 0.9 be on the graph? This way, right? Okay, so if I'm going like 0.9, 0.99, 0.9999999, where is the function going as I go towards 1 from below? Negative 2. See it? Remember, limits are always y values. So as I come towards negative 1, as I come towards 1 from below, from the left, my function is going to negative 2. How about this one? What's the limit as x goes to 1 from above? Be confident. I think I already heard the right answer. Where's my function going as I come from the right?
4. 5.
y value. What y value? 0. Check the y tick marks. This one's going towards a y tick mark or y level of -2. This one's going towards a y level of 0. So what's this one? Look at your shoes. Look up here. DNE because do they match?
No.
No. This guy's going to an In-N-Out in one location. He's going to get the burger. That's the new location. He's going to the old location. He's not going to get his burger. The limit does not exist.
He's gonna get complex.
But he's going to get some. But from below, this guy's headed to a height of -2. This guy's headed to a height of 0. But the limit does not exist. Might want to take a picture of this one. But I think with that, guys, I've been very specific about the hints for tomorrow. Remember, test reviews. You do not need to do directions or problems. You're just practicing. Practice the other evens on the worksheet. Practice the test review. Has anybody started it and have any questions? No? Tell me.
If the limit doesn't exist,
Yeah, you may. If the limit does not exist, oh, Tony, you can just say because they don't agree.
Oh.
Or you can say the one-sided limits don't match. You've been using the word match a lot. Yeah. But number 6, the limit does not exist because either side does not agree or does not match. Hey guys, number 7, does the limit exist as you come towards 1?
Yeah.
Yes, because the whole doesn't matter. What matters is, are they in agreement? Are they matching in where they're headed? That one's a no, the limit does not exist. This one's a yes, the limit does exist. And are there any breaks or any problems in this guy? All limits will exist for him. Are there any breaks or any jumps in this guy? Nope, the limit exists for everybody on him. The limit will only not exist if the two sides do not agree. Oh, sorry, I just threw that on top of the test review. If you guys needed to plug into a table, just because some of you are just like there's not enough time to start, do you see why they would do 2.9, 2.99, 2.99? 3.1, 3.01, 3.001. Remember, tomorrow I said you're going to have one table you're going to have to fill in. Just one. And you're going to get to use your calculator. Anybody have any questions on their calculator I can answer?
Yeah, we're saying thin, but.
But have fun. Good try. I think there are even 2 bonuses on there tomorrow. Yeah.
When you're doing the part where it's like y1 and then like 1/2 plus
Yeah.
like how do you get the y1?
Okay, well first of all you have to go to your y equals and put in a function.
Yeah.
Okay. And then once you put in a function, then help me do alpha and fractions. Use a parenthesis like that. Wow, kids, if you need something, email me or text a friend.